Welcome to the shop. This is the basics of welding and cutting safety from Weld Fusion, or a summary of the things that everyone should know before they start. This is an overview of the most common hazards along with the personal protective equipment and safe practices that you can use in your own shop to stay safe. We'll also cover important resources and where to find more safety information should you need it. Let's get started. Do you know what safety resources to use for your application? Well, the best place to look for a list of comprehensive safety information that is relevant to you is in the Equipment Owner's Manual, because the info in that manual is specific to your system. You'll also find labels on equipment that likely use symbols to call out hazards. Pay attention to these labels because they point out dangerous parts of the system that could be a concern. Safety data sheets, or SDSs, contain proper storage, use, and handling of chemicals, gases, and substances. So that's where you look for info on the safe handling and use of consumable items like filler metals and gases used in welding. The American Welding Society is another good resource. There you can find ANSI Z49.1, which is the safety standard for all welding and cutting processes, currently available as a free download, along with safety and health fact sheets and the AWS Welding Handbooks. And don't forget, if you're working for someone else, they probably have shop or worksite rules that you have to follow. But if you're working in your own shop, you just have to follow your own rules. Just be sure you're covered. And hey, welding and cutting can be dangerous activities, and welding manufacturers want you to read the Equipment Owner's Manual and follow all safety precautions prior to installing, using, or servicing the equipment. This training is not a substitute for reading your manual, but it does highlight the things that everyone should know before they start welding. Do you know the difference between danger and caution? These important safety terms are used on labels to indicate the potential injury if precautions are not taken. It's likely that you'll see these terms or an exclamation triangle symbol in your owner's manual and on your equipment labels. Danger indicates that death or serious injury will occur if not avoided, so a hazard with this marking is the most severe. Warning indicates that death or serious injury may occur, and caution means that minor or moderate injuries may occur. In all cases, you should take appropriate precautions to avoid the potential for injury. Other important markings include the safety symbols that are used in place of or alongside of text for hazard communication in manuals, on signs, and on machine labels. Symbols are used because they're believed to be universally understood regardless of your native language or background. And for the most part, that's true. These images depict some of the most common safety hazards for welding and cutting. And remember, this is a summary of all the possible symbols that might be in your owner's manual or on your machine labels. So check your owner's manual and let me know if I missed any. Here are a dozen of the safety symbols you might see depending on your equipment and what you're doing. In fact, there are dozens more symbols and way too many to list here. So once again, check that owner's manual to see what applies to you. Now, these hazards are serious, but don't let that scare you away from welding. All of these hazards can easily be avoided, and now we're going to talk about how to do that. Let's dive into the most common safety concerns for welding and cutting. Up next is a description of each hazard along with the precautions, personal protective gear, and safe practices that you can use to prevent incidents and injuries. First up is electricity, which is probably no surprise because arc welding involves electricity. And electricity is dangerous because you can get shocked, so it's serious business. Now, there are two main areas of shock potential in an electric welding or cutting system. The first is, yep, you guessed it, where you plug the machine in to get power. This is the primary side of the system, where power comes into the machine. This power is high voltage and low current. Generally, the higher the voltage, the greater the potential for shock. This is the machine output side, which is also called the secondary. And it's where the power is delivered to the welding circuit. To avoid shocks, don't touch live electrodes or electrical parts. Insulate yourself from the work and always wear dry, insulating gloves. It's a good idea to have a second pair of gloves in case you sweat through the first pair. And I can tell you from experience that if you feel a little tingle, you're overdue for some dry gloves. You should also inspect your equipment. Make sure that you have a good work connection and repair or replace any damaged cables. Keep guards and covers in place when you're operating the equipment. Hey, they're there for a reason, right? And always disconnect power before servicing any of your equipment. And that doesn't mean just flip the power switch on your welder. You have to actually unplug it from the wall or switch off the circuit breaker, or there's still power coming into your primary switch. The next common hazard involves bright light and radiation. Welding produces bright, visible light that we can see. And arc welding also produces infrared and ultraviolet radiation. These arc rays can burn your eyes and your skin, so you have to cover up. Eye protection for welding always begins with safety glasses. And those safety glasses should meet ANSI Z87.1 specification for impact resistance, side shield protection, optical clarity, and UV protection. And from there, eye protection for welding and cutting really depends on the application. Shaded filters for welding and cutting block the harmful light that's generated during the process. And shade darkness is indicated by a numbering system up to about 14. And the higher the number, the darker the shade. Cutting glasses, goggles, and face shields that are used with oxyfuel typically require a lighter shade than arc welding because the light is less intense and the flame doesn't produce infrared or ultraviolet radiation. So a number 5 shade is common for oxyfuel welding or cutting when you need to see past the bright light. And it's not mandatory to cover your entire face because the exposed skin around the mask won't get sunburned. Although a full face shield does block more heat than a pair of tinted safety glasses. Now, arc welding is a different story. And arc welding requires a full face mask for maximum protection from arc rays. Shades for arc welding are typically darker than what's required for oxyfuel. Number 9, number 10, and number 11 shades are common, depending on your process and the welding current or amperage that's being used. The higher the amperage, the higher the shade is required to block the light. So how do you know what shade you need without going through trial and error and ending up seeing bright spots? Well, that depends on what you're doing and how much. Oxyfuel is fairly straightforward. You need a number 5 shade. But arc welding processes typically require a shade number 9 through as high as a number 14. Auto darkening helmets are a huge benefit for welding. The lens lightens in shade to improve visibility when you're not welding and automatically darkens when you strike an arc. This eliminates the need to constantly raise and lower your hood between welds, and it makes it a lot easier for beginners who often struggle with a fixed shade hood. Many auto darkening hoods also have lighter shade settings for cutting and grinding, so the same helmet works for all applications. And I wear my safety glasses right underneath my welding hood because I've had sparks bounce around inside my helmet more than once, so it's nice to have a little extra protection in there. Welding curtains or screens are also helpful protection in the shop. These are typically used to shield the welding zone in order to block the intense light from affecting others that are nearby. If you're welding where others can see the arc, use a welding curtain to shield them from the bright lights. These are typically designed to prevent accidental arc flash, and they're not normally dark enough to watch the arc for long periods of time, so I wouldn't try that. I have seen welding screens that were much darker, but they're not all that common. To protect yourself from bright lights and radiation from welding, you need to shield your eyes and cover any exposed skin. Always wear safety glasses that meet the ANSI Z87.1 requirements. Then use the appropriate goggles, face shield, or mask with a properly shaded filter based on the process you're doing and the intensity level that you're operating at. Cover all your exposed skin in fire-resistant or FR-rated material. Wear a cap to deflect sparks and spatter, and use ear protection to keep sparks out. Aside from bright light and radiation, welding and cutting involve heat, lots of heat, like enough heat to melt steel. So materials in the welding area could be and are likely to be very hot. At the same time, welding and cutting generates sparks and flames, and you need to protect yourself from all of these. When you're welding and cutting, you're literally playing with fire. So it's important to wear fire-resistant clothing for maximum personal protection. Leather, cotton, or wool are good natural choices because they are flame resistant. Cotton can be treated to improve its flame resistance, which is commonly used for the lightweight welding jackets you might see out there. Leather undoubtedly provides the best protection, but it's hot and heavy to wear. As a result, many welders opt for treated cotton or specially made flame-resistant materials, using leather only for extreme conditions where maximum protection is needed. Your personal protective gear, or PPE for welding, should include a welding shirt, a jacket, or sleeves that cover your skin. Remember, any exposed skin will burn quickly when welding, as though you spent too much time in the sun. Jeans, cotton pants, or dedicated welding pants are required to protect your legs. And they should be in good condition, which means no rips, no tears, no frays, because they may not keep sparks out and frays can more easily catch fire. Leather gloves, leather work boots, and a cap or beanie may also be needed depending on just how many sparks you're throwing. Do not wear man-made plasticized materials for welding and cutting. So no nylon, no polyester, no rayon, and other materials that are not flame resistant because they might melt, ignite, or even cause severe burns. There are lots of choices for hand protection. Welding gloves have traditionally been made from leather of differing thicknesses, depending on the process they're intended for. Fire-resistant gloves, such as Carbonex, are also used with leather to improve breathability, flexibility, and reduce overall weight. Gloves can be made from 100% FR materials, but those are typically just for handling hot metal and not so much for welding because they don't provide the same electrical insulation that leather would. TIG gloves are normally made from the softest leather. They're the thinnest type of glove and usually the least durable. Delicate TIG work at low currents requires little heat insulation but demands high dexterity for accuracy and precision. To preserve your TIG gloves, only use them for welding. Use different, heavier gloves that are more durable for metal preparation, sanding, or grinding, and you'll thank me later. TIG-MIG combo gloves are thicker than those recommended only for TIG. These gloves trade in thin flexibility for a little bit of extra insulation, durability, and heat resistance for higher amperage welding. They're sometimes on the thin side for heavy-duty MIG or flux core welding, but they do well for low-amp wire feed processes. MIG stick combo gloves are the thickest and most durable glove, usually designed to handle the high heat of stick, pulse, or spray transfer MIG and flux core welding. They're the least flexible type of glove, but they offer the most protection and usually last the longest time. As a tip, you can mix and match glove types depending on what you need and where the heat is. Many welders use a thin glove on their torch hand, which is away from the heat, and a thicker glove on the hand that's closer to the heat. As a tip and a warning, do not use mechanics gloves for welding or cutting unless they are specifically FR rated. Many mechanics gloves that are sold out there have leather palms with nylon backing that is not flame resistant. That means they will not stop sparks and could melt or ignite and cause serious burns on your hands. So do not weld in mechanics gloves. For extra hand protection, consider using a heat shield over your welding gloves. These can prevent burns and blistering from a hot welding arc or when resting your hand on some hot work trying to improve your stability. MIG and flux core designs are normally leather construction with an aluminized heat shield to block and dissipate the heat, and they use palm straps to hold the shield in place. TIG designs focus on insulating the resting part of the hand, usually the pinky and sometimes along the outer palm of the side of the hand. This allows you to prop your hand for support and be steadier with the torch. But the work can get hot, so extra insulation can keep you welding longer and keep your hand a little bit cooler. Now, in addition to protecting your hands, you need to protect your feet. Welding boots are an important part of foot protection, especially if you weld professionally or all day. Boots should be made of leather and FR materials, right? So they block sparks and they're non-flammable. Some work boots have nylon facets and should not be used for welding because basically if a spark hits them, they're going to melt.
Better boots use non-flammable stitching like Kevlar, so they hold up better in the shop. And many welders prefer boots with no laces because they keep sparks out better than laces, which can trap sparks or hot metal and increase the chance of burning your foot. Steel or safety toes are options, and metatarsal coverage might be required depending on the job site. Boot soles should be slip, heat, and oil resistant for maximum stability and protection. And remember, boots should keep sparks out, so never tuck your pants into your boots. Always wear boot cut pants or jeans that fit over the boots, covering the opening and helping to block sparks or keep hot materials from falling in and giving you a hot foot. To avoid burns from hot metals and hot parts, assume everything in the weld area is hot, because it could be. Heat from welding can travel through parts, tables, clamps, and other tools in contact with the work. Metal is conductive, and metals like copper and aluminum are superconductive. So the part could be hot enough to burn your skin a long ways from the weld area. So just be cautious. Use gloves, pliers, clamps, or metalworking tongs to handle hot metal. Allow parts to cool before you handle them. And some material must be air-cooled slowly, and other common metals you can actually quench in water to room temperature without much risk. Just don't try that with cast iron or anything that's alloyed, because it could crack. Along with generating lots of heat, the hot sparks and flames from welding and cutting can cause burns, fires, and even explosions. As a rule, you should clear the weld zone of all flammable materials, liquids, and gases. Remove any paper, cardboard, shop rags, garbage cans, wood, sawdust, fuel containers, and anything else that could ignite or melt. The American Welding Society recommends clearing a 35-foot radius around welding if sparks cannot be contained. And that's a big area. And not all processes throw sparks that far, but some could. So it's a good idea to weld in a contained area, like in a corner, a booth, or a dedicated spot that will contain the sparks and spatter while also blocking arc rays. You may also choose to weld outside, but that brings up a whole other list of concerns, like grass and leaf fires. Regardless of where you weld, just remember that even the best plans don't always work out, and sometimes the unexpected can happen. Ask me how I know. So, it's a good idea to keep a fire watch during and after welding to make sure any flames can be quickly snuffed out and dealt with. The American Welding Society recommends a 60-minute fire watch after welding, which was increased from the old standard of 30 minutes, and I'm not sure why, but that's usually how long it takes me to clean up anyways, so it's not a big deal. And spending a little bit of extra time to be vigilant after welding is good extra insurance against a potential accident. Fumes and gases are another consideration for welding. Fumes are produced by many welding and cutting processes, and you should avoid breathing them because they often contain metal particulates and compounds that are not good to breathe in and may cause issues over time. You should avoid breathing the fume plume, which may be especially thick from stick or flux core welding. You should use ventilation or wear a filtered respirator when ventilation is limited. Shop ventilation may be natural if the building has enough size that it doesn't accumulate, or it may be mechanical. And a shop may have a centralized exhaust system or use what they call source extraction, where ventilation is placed directly at the welding operation. Gases used for welding and cutting are often heavier than air, and this means they can accumulate and cause serious issues. Fuel gases can ignite, and shielding gases can displace breathable air in confined spaces or where ventilation is limited. Fuel gases are scented, so you can typically smell them if there's an accumulation, but shielding gases are largely inert, so you can't see them, smell them, or taste them, and that makes them dangerous. So what's a confined space? Well, this is actually any area that's not intended for human occupation, and as a result may lack natural ventilation, which would allow welding gases to collect. Because the gases are heavier than air, they accumulate from the bottom up, and they displace that breathable air, which creates the potential for asphyxiation. Pressurized cylinders are another source of potential hazards. Welding and cutting processes use gases for different reasons. Whether you're using a fuel gas or a shielding gas, it's likely they'll be delivered from a pressurized cylinder. Pure oxygen and fuel gases are used for oxyfuel. Compressed air is used for low amp plasma cutting, and inert gases are used for MIG and TIG welding. High pressure cylinders used to store oxygen, argon, and argon mixes are made from seamless, high strength steel. They have dual seating valves and should be used in the fully open position to prevent them from leaking around the valve stem. Internal pressures of these cylinders can be as high as 2,200 pounds per square inch, or PSI. Low pressure cylinders are used to store fuel gases, like propane or acetylene. These are welded containers made from plain old carbon steel. They do not have a dual seating valve, so it's recommended to operating with the valve open just enough to maintain flow and pressure. That way, it's easier to turn off the valve in case of a fire. And that's the best way to stop a fire. Turn off the source valve. Remember, the weakest part of any cylinder is the valve, so every effort should be made to protect it at all times. The following rules apply for all safe cylinder use, handling, and storage. Number 1, all cylinders must be stored and handled properly. Number 2, all cylinders must be clearly marked for contents. Number 3, all cylinders must be secured during use. Number 4, caps must be used during transportation or when the cylinder is not secured. Number 5, all cylinders should only be filled by an approved supplier. Here we see proper safety precautions for storing and using pressurized cylinders. They are secured in use, stored with caps on, and clearly labeled for contents. Arc welding produces electromagnetic fields, or EMF, which can cause health issues and even tissue damage in extreme situations. High welding current at high frequencies using AC or pulse welding tend to increase the intensity of the electromagnetic field, and levels are highest near the welding cables. People with pacemakers or other internal medical devices should keep away from welding. Route the electrode and work cables together to minimize magnetic fields, and keep cables away from your body whenever possible. Position your body outside the welding loop or the secondary loop, and if that's not possible, you can look into EMF shielding devices. Welding shops are loud places, and general shop noise can exceed allowable decibel limits. Whether it's noise from the process or surrounding equipment, hearing protection is often required. As a side benefit, earplugs prevent sparks, metal, grinding dust, and other garbage from going into your ear. Metalworking equipment and processes make sparks which can travel, as we discussed, up to about 35 feet from the source. Many processes also generate hot weld spatter. Grinding, beveling, and other metal work usually involves tools operating at high RPMs with enough power to cut metal. Many of these operations produce sparks, dust, or debris that can become a high-velocity projectile, posing serious hazards. When grinding discs and tools fail, they often launch fragments that are extremely dangerous. Always wear eye protection that includes safety glasses, again, that meet ANSI Z87.1 requirements, with side shields, or wear goggles, a mask, or a dedicated grinding face shield to protect yourself. Be mindful of others in the area when performing these activities to be sure they're safe and won't potentially be in harm's way. Welding wires and electrodes are small, sharp objects that can puncture clothing and your skin. Be mindful that MIG or flux core guns feed wire at hundreds of inches per minute, so that wire comes out of the gun pretty fast. Only press the trigger when you're ready to feed wire and point the gun away from yourself and others so you don't get harpooned. Tungsten is sharpened to a point and extremely hard. Keep your hands and body away when sharpening or preparing. Use hand, eye, face, and body protection when grinding your tungsten. And only use an approved grinder with guards in place. Store your gun, torch, or electrode holder so it can't accidentally fall and stab someone. Another way to minimize the risk of injury is to practice good housekeeping. You are responsible for your work area, and a clean work area is a safe work area. A messy work area slows you down because your mobility is limited and your tools are unorganized. Sloppy cables and clutters create tripping hazards and slipping hazards that can easily be avoided. Cleaning your space also removes harmful dust that shouldn't be allowed to accumulate, right, due to its effect on people and equipment. As a tip, you can minimize cleanup time and effort by planning ahead. Lay out your tools and equipment with consideration for scraps, spares, and trash so you can minimize the mess you create. Take care of your tools and materials while periodically reorganizing through the job. Future you will thank you for this effort. And be aware of unique hazards that you might encounter. Remember, each situation is unique and you shouldn't work beyond your training or comfort level in order to avoid accidents. Many specialized welding jobs require extensive training far beyond the basics, and you need to understand the hazards before you get into a bad situation. Here are some general shop rules you should follow. Welding is a fun and enjoyable hobby, and it can be a great career, but it's serious business with life-threatening consequences. So have fun and enjoy welding, but be safe and follow the rules. They're there for your own good. First, clear the weld zone and remove all flammable and combustible items. Safety glasses should be worn at all times, even under your hood. Sparks and other objects can bounce around inside your welding mass and pop right into your eye. Every time you lift your hood, you expose yourself to the potential for an eye injury. UV blocking safety glasses are also an added line of defense against arc rays and accidental arc flashes. Appropriate clothing and attire should be worn at all times in the shop. This includes flame-resistant clothing that covers all skin. No nylon, no polyester, no rayon, no spandex, because they can all melt and burn your skin. All jewelry and watches should be removed, because metal is a conductor and you don't want to accidentally bridge the gap between the work and ground and get shocked or burned. Hearing protection is a good idea, but required when sound levels are excessive and when performing certain operations. Remember, earplugs also keep sparks and spatter from going into your ear, which is a pretty uncomfortable feeling. Keep all guards in place. They're there to protect you, and removing the guard places you in harm's way. This goes for grinders, machines, wire feeders, saws, shears, and any other metalworking equipment you might use. Removing guards exposes dangerous electrical and mechanical hazards that can easily cause serious injury. Use the proper PPE for the activity. You may not always be welding, so understand and take precautions for every activity that you do. Ensure good ventilation and don't breathe welding fumes. Use a filtered respirator if ventilation is poor or not possible. Direct sparks away from people, equipment, work, and other items. Be mindful when grinding, drilling, cutting, or performing any activity that makes sparks, spatter, or chips that could injure. Secure all cylinders when in use. Store cylinders with a protective cap in place to protect the valve. Remember, that's the weakest link. Only use gases that are clearly labeled with contents, and turn cylinders off when not in use. In the shop, you should act professionally and responsibly, avoiding horseplay. While we plan to have fun and enjoy our arc time, it's important to keep in mind that we're working with equipment and machinery that can be very dangerous, even when it's not in use. Clean up after your tasks, organize your work area, and remove tripping hazards. Inspect your equipment for loose or damaged cables. Perform routine maintenance. If you grab your work clamp and you find it hot, it's a good indication that you've got a problem and you should dig into it. Ask for help when using new equipment or doing something new. Only work to your skill and training level. Some activities require specialized training, and teams of people tend to be successful and safe. Seek proper training if you intend to perform any specialized welding. All right, now let's do a safety check. If you look at the picture here, how many safety issues do you see? The safety issues that I found are no safety glasses or cutting shade, the pants are tucked into the boots, the person is not wearing welding gloves, that is not an approved torch holding position, flames are directed toward the hoses and his body, there's trip hazards all around the site, and I think he's even standing on the gas hoses. Did you find any more that I missed? Well, this person is clearly not ready and should never have lit the torch. That's the last thing we do before we begin the cut. Let's break down the situation and come up with a better approach. First, they should prep the welding or cutting worksite location and get everything ready to go. Then they should set up the equipment close to the work but out of the way in case things move. They should be dressed properly and completely, including eye protection. They should then approach the work all ready to go. But before lighting the torch, look around, assess the area for issues or concerns, and then put on the welding or cutting shade. Then do the work, clean up, and maintain that 1-hour fire watch. So this has been a summary of the common welding and cutting hazards, along with precautions that you can take to avoid incident and injury. Remember, each situation is unique, and it's up to you to practice safe habits, good housekeeping, and be aware of dangerous situations so you can take action and avoid injury. For more information, refer to the sources here. In closing, it's important to note that welding, cutting, and allied processes are dangerous. They present hazards that can result in severe injury and damage. Proper precautions are necessary to protect yourself and others from welding hazards. Read and follow all equipment labels and the owner's manual carefully before installing, operating, or servicing any equipment. Start every activity with safety in mind and do the necessary research if you're unsure or attempting something new. Take the necessary precautions to avoid injury and property damage. Only perform work or tasks within your training and qualification level. Don't take risks, follow recommended practices, and avoid incidents. Stop, think, and act. Have a safety plan in place in case of an incident. And otherwise, once you have everything out of the way, enjoy your project.
And there you have it. These are the most common hazards associated with welding and cutting. So wear your PPE and take proper precautions and stay safe out there. Let's go make some sparks.